lecture, we are going to discuss about basic of FET and its parameters. So what are these basics? So we are going to discuss about its thermal runaway. As we discussed about VJT, there is thermal runaway placed in VJT and UJT. So what is thermal runaway first? Thermal runaway, that means if temperature increase, due to this temperature increase, there is an increment of collector current. So due to this collector current increment, there is a power dissipation generated, and due to this power dissipation generated, there is a heat produced, and due to this heat, there is an increment of temperature. So this is basically a chain. If there is an increment of temperature, so continuously it is going to be increased, and this reinforcement is known as thermal runaway. And due to this thermal runaway, we can see the transistor gets damaged. So we have to avoid this thermal runaway in transistor. So here we can see this is the thermal runaway in FET. So there is a thermal runaway in BJT due to NTC, because BJT is NTC. NTC meaning it is negative temperature coefficient of resistivity. That means increase in temperature, resistance is decreased. If there is resistance is decreased, that means temperature continuously going to be increased. So thermal runaway placed in this transistor. Now about FET, there is PTC. It is known as positive temperature coefficient of resistivity. That means if increase in temperature, then resistance is decreased. So automatically it can control the increment of temperature. So we can avoid thermal runaway in FET. So it is the biggest advantage of FET rather than BJT. So here we are going to discuss about MOSFET. MOSFET is flat temperature coefficient of resistivity. That means changes in temperature, so drain current does not increase with increase in temperature. So that means resistance of MOSFET remains constant irrespectively. So that means there is no change in resistance. So it is known as flat temperature of coefficient in MOSFET. So this is the thermal runaway. So basically we can avoid thermal runaway in FET and MOSFET compared to the BJT. So this is the one of the advantage. That's why we are going to use mostly prefer FET rather than BJT. Now let us discuss about its parameters. So number one, it is transconductance. So conductance, that means it is G. Transconductance, here we can see it is denoted as Gm. It is basically Gm is equal to delta ID upon delta VGS at constant VDS. So at constant VDS, we can see the ratio of delta drain current upon gate to source voltage. So that is known as transconductance. So here number two parameter is dynamic drain resistance, which is known as RT, and it is the ratio of drain to source voltage to the change in drain current at constant value of gate to source voltage. So here we can see this is the equation of RT, dynamic resistance. RT is equal to, it is delta VDS upon delta ID at constant VGS. So this is the second parameter. Now here we can see this is the third. So if we are combining two parameters, so here we can see this becomes amplification factor, which is denoted as mu. It is defined as the ratio of change in drain to source voltage to change in the gate to source voltage at a constant value of drain current. So basically we can write mu is equal to delta VDS upon delta VGS at constant ID. So that means it is known as amplification factor mu. Basically we can write here mu is equal to delta VDS upon delta ID, which is basically dynamic resistance RD, into delta ID upon delta VGS. So it is basically GM, transconductance. So here we can see if I cancel out delta ID, then it becomes delta VDS upon delta VGS. So it is basically amplification factor. So it is equal to the product of drain resistance and transconductance. So these are the parameters for FET. Now here next topic is JFET as a switch. As we discussed in our first lecture that FET is also a transistor, so we can use it in as a switch or as an amplifier. So here we are going to use it as a switch. So JFET and MOSFET can be used as a switch and as an amplifier. So for operating FET as a switch, it should be biased in cutoff region and ohmic region. So there are three various types of regions are available for FET. Number 1, cutoff region. Number 2, ohmic region. And number 3, saturation region. Whereas we have discussed in BJT, there are 3 regions: cutoff region, active region and saturation region. Here we can see there is a little bit change in regions. So if your application is for amplification, so it should be operated in saturation region. FET can be connected in shunt switch or series switch. So basically shunt, that means it is connected in parallel. So we are going to discuss about JFET as a switch in shunt as well as in series. So here we can see this is the JFET as a switch. So here we can see in this figure circuit diagram there is a connection in shunt. Why it is shunt connection? Here we can see in this figure JFET is connected across this output, V output. That's why it is known as shunt switch, right? So here we can see V in, that means input voltage, then resistor, then JFET, and across this JFET there is a output voltage. So there are various cases, 2 cases. Case number 1, we have to remind the characteristics of JFET as we discussed in first lecture. So here case number 1, for VGS, that means gate to source voltage, which is also known as controlling voltage. VGS less or equal VGS off. Then JFET acts as a open circuit. That means if your input is minus 4, minus 5, minus 6. So remember this thing, if your input more and more minus, so there is a depletion region increase in the channel. And due to this depletion region, the current flow, or we can say precisely drain current, stops at the end. That means basically we can say it is open circuited. So we can see here case number 1, if VGS is less or equal VGS off, then open circuited, that means open switch. Now here we can see case number 2. In case number 2, if we applied VGS is equal to 0, that means depletion region is initially generated. So there is a flow of current, or we can say drain current. So there is a closed switch. Here we can see this is the equivalent circuit of JFET. In first we can see this is the open circuited. So in place of JFET symbol, here we draw open circuited, right? So input to output we will get. Here we can see in place of JFET symbol there is a closed switch. So input to output will get. So this is the equivalent circuit of shunt JFET. Here we can connect JFET in series switch. So here we can see in this figure in circuit diagram that it is called as series switch because JFET is connected in between input and output. So Vi and Vo, in between Vi and Vo there is a Jfet symbol. So that means it is in between input and output which is connected in series. So that's why it is known as series switch. So here if we connected in series switch, we have to place resistor across this output voltage. Here we can see in circuit diagram. So if we applied here various case number 1, as we discussed in shunt, VGS is less or equal VGS off, the Jfet acts as open switch. Similarly here there is no change in series and shunt, so it becomes open switch. Remember this thing, VGS off, that means it is the below cutoff region. If your input is minus more, that means it is below the cutoff region, and below the cutoff region there is no flow of current. So here we can see it is open circuited. Now in case number 2 we can see if we apply VGS is equal to 0, that means it becomes closed switch. So that means there is a path input to output, so there is a flow of current which is known as closed switch. Here we can see below, this is the case number 1 which is open circuited, and we can say RDS is approximately infinite. So it is approximately infinite, that means no flow of current. So here we can see below, this is the case number 1, and above here we can see this is the case number 2, whereas we can see VGS is equal to 0, so there is a closed switch. That means RDS is much more less than RD. So this is the Jfet as a switch. So basically it is also a transistor, like we have discussed in BJT. Transistor applications are as a switch and as an amplification. So about Jfet we have discussed earlier how it works as an amplifier. Similarly here we discussed about its second application, that Jfet works as a switch. So this is the last topic of this chapter. If you have any query related to this topic or any topic of this chapter, you can mail me on this email address. Till then, see you soon in next coming lecture. Keep learning, keep reading. Bye bye.